How's everyone? So the homework, you had the first homework turned in on Friday, and then it was, Mingyu was really speedy in returning it back. So if you haven't picked it up, the file is here. Please do that at the end of the class, not right now. Since this is the first homework, I think there are certain things that we need to just repeat. So if for some reason you were delayed with your homework, you can always submit it electronically. So take a photo of it if it's handwritten, or just submit a file electronically and then submit the printed version later. Printed versions are always way easier to grade. So basically that speeds you up about 3 to 4 times to just have things in print. But that said, use the technology to your advantage. You have phones with pretty good cameras, right? If you need to prove that you completed the homework, we'll prove it using what's available to you. Sometimes files upload or don't upload. If it's electronic submission, you can always prove on your computer that you had the file last saved just before the homework was due, and that's a proof good enough. Okay, so something like, and then also if you are using a cloud to store your files and folders, which is what I highly, highly suggest. Let me repeat this. I highly, highly suggest. I can't make you, but it's gonna save your life in certain situations, especially when something happens to your computer, or you leave it behind in your apartment, and you come to the 3rd floor here, and you can find in computer lab you can actually access your files. So it can be a lifesaver, especially as the semester moves on. Okay. All right. So other than that, I want some also feedback. If everything is working just fine, no feedback needed. But also email me with any other concerns that you might have about the process submission. It's beginning of semester, so Mingyu was really fast in returning the homework. Overall, he has, according to the rules set up by the course, 8 days to do that. Okay? So if you're concerned with him not returning homework on time, I might not know about it, so you let me know. Okay? So you act as a double check on TA. So give me feedback. If you're not comfortable walking to me in person, or you're not comfortable emailing for some reason, you can always use that anonymous form that I advertised at the very beginning of the course, or it's also in your syllabus. Okay. So, however it's comfortable for you to communicate, just communicate. Whatever works for you, it works for me. All right. So let's get back to our lecture. So last time we actually, we've been talking about how we're going to learn programming, and last time we actually started. So we started in a programming language called Python. Is that the only programming language we could possibly use? Is that the only programming language you will ever use in your life? No. And you don't even know what you're going to use 20 years from now. So expect change. Okay? These things are constantly evolving and getting better and different, and technology is evolving and getting better and different, and programming languages have to go with it. Just remember what computers looked like in 1946, if you remember what I showed a couple of times ago, and what do they look now? I mean, they're often wearable devices such as phones. Even your rice cooker could have a little computer in front of it, right? So just move along with the technology, evolve better. Okay? So, but nevertheless, what we're actually doing here is pretty basic. What we're going through, the rules are pretty similar in most other programming languages. So once you're prepped in one of them, you're good to go. In most of them, it takes a little, of course, to get into the syntax, but syntax is pretty similar. All right. So I have chosen to use Spider because Spider is in a sort of an environment that makes programming a little nicer. Okay. So it has certain niceties to it that help you check your code. That said, from the only one thing you can use. There's PyCharm, there's different other software. The choice of this little nice environment in which we are going to program doesn't really matter. We will actually switch to web browser version of it, which is called Jupyter Notebooks, which definitely it has improved the way I teach, and it just made the communication easier. And it's these days, sort of through the web browser, which you have on your phone, you can communicate to pretty much any other computing system, which is pretty powerful. So this Spider is an environment that kind of talks to my computer really well, but technically through a web browser, I could communicate with any other computer that is on the net. And that extension for any kind of future things you're going to do with the programs is pretty powerful, which is why after a little bit of an initial exercise is done in Spider, I will move to Jupyter Notebooks. Okay. Each has pros and cons, but that extension of being able to, basically there's something called Texas Advanced Computing Center here that has loads and loads of computers and different computing options, and you can basically communicate with all of them through that web browser, which is pretty powerful. So in any event, let's get back to our fundamentals. So one thing that we learned is, okay, we have defined matrices, arrays, one-dimensional or two-dimensional or three-dimensional, as very important ways to store the data in petroleum engineering or pretty much in any other branch of engineering or science. Well, we need to tell the computer how to do that. And computers are very good at repeating a task numerous times. They can make your life very, very easy often by doing so. But also, in essence, stupid. You have to tell them they don't have a mind of their own. Well, they're starting to have a mind of their own. But it's still a programmed mind. Okay? So you have to tell them exactly what to do. Otherwise, mayhem starts. Okay? So we have to first clearly say, okay, what it is that you want to store, how much of it. So that's what we say. We call those things variables. Okay? So we have to tell computer what to do. Now, certain things it can recognize, so they're somewhat smart, but again, they're programmed to do so. But we have to nevertheless be clear and concise. Okay? So every time you want to, in the future, punch your computer for not doing what you wanted to do, recall that the computer is doing precisely what you told it. Okay? So your communication has to improve. So let's just go back to some standard things. So when I type in Masha equals to 5, what am I doing? I'm defining a variable. So this is not now my name, even though I decided to just type in Masha. Okay? It is a variable, numerical variable, and 5 is stored in it. I can actually look up here in Variable Explorer, which is a nicety that comes with Spider, or any probably other environment that makes computing a little easier. And I can see that the type there is integer, size is 1, and the value stored in it is 5. So it has somehow figured out that I want to store an integer. If I actually, and I can overwrite this, if I put 5.0, okay, it will overwrite what I just did. Okay? So initial integer variable is gone, and now it's float. Again, computer just did what I told it to do. It didn't question me. Hey, do you want to overwrite Masha? You really want to overwrite it? Okay? It just did it. So you have to be careful about that. And now it recognized, oh, it's a float. And floating point is computer science name for a real number. Okay. So basically, that's a single variable. I could also introduce text, and I'm just going to say, well, my name is Masha. And now this text is green. It recognized it as something else. And I put quotes, and those quotes indicate that this is a string variable, so it's going to treat it as text, not as a numerical value. Now, as far as regular operations with these variables go, we can do standard things. So I can now say, hey, Masha plus 6 is 11. So I can do any kind of standard operations you would expect to do with numbers. However, it's going to have a hard time doing that with that name, because name is a string. Yes?
Is it at all bothered by you trying to add an integer to a floating point number?
It's not. It's going to do something. So in this case, it's going to basically revert everything to, or put everything to float. Some, and this is a great point, some other programming languages might be really bothered, okay, and will not allow you to do an operation between an integer and a float. And the reason is because those two things are stored in memory really differently. So if a programming environment allows you to do that, that means that it's programmed to be nice, okay? So there is an additional layer of programming that will say, aha, so-and-so is trying to do float plus integer, therefore I'm going to convert everything to float, which is sort of like more encompassing, okay? And store the result as float, or rather report the result as float. Is this result 11 stored? So if I don't store it, or I don't choose to store it, I'm not going to have it, and I'm not going to be able to work with it later on in my program. Okay? So those are some very basics that we started with last time. What I want to now continue with is with more advanced stuff, and that is basically matrices and 1D, 2D arrays. So let's move on with that. With that, I'm just gonna, before I go on to that, I'm gonna just motivate and introduce a very helpful package. So we're gonna now learn how to enter matrices and vectors. One simple thing is always manual entry, and you want to do that up to size 3 by 3 or maybe 5 by 5. Here and there, you're going to make yourself enter something larger, but then after that, you're not going to be too happy. We overall want to be able to just read in lots of data. So Dr. Balhoff, I'm going to pick on you right now. What is the largest representation for reservoir simulation that you work with? What was the matrix for the 3D array? For permeabilities, yes.
So if I coded it myself, probably 100,000, but of course, billions have been used by the simulators.
Would any of you type in 100,000 numbers? And would you do so well? Probably not, right? So these are very large, so we typically want to import them in some way. They're typically stored in a file. That file should have a format or some, we have to know how to read what is stored in that file. Can you give me an example of a file format?
STL.
STL is one. Where did you use STL?
3D printing.
Excellent. So that's STL happens to store, it stands for stereolithography, and it happens to store triangulated surfaces. And we use those for basically anything that you want to design, okay? And then 3D print in this case, but also work with it in software. So your reservoir would be in STL file, okay? And it's discretization. Then we use STL. Any other day-to-day, anything on your computer? PDF, JPEG, PNG, images that you take and share, right? So all of those, the moment they have a specific that means that there is a format that is sort of registered that everybody knows what to do. And your computer knows when it says .stl or .png or so forth, what to do and which of the programs that you have on your computer can actually open it. You can also define a format yourself, except that you then have to communicate to whoever you're sharing it with what is in that file and how to read it. Okay? And possibly you can send a little program that does it. So there's no problem you defining. So we're going to import and export some data to files because that can allow us to do larger, way larger arrays than we could just type in. Okay. So we will basically rely on the most common sort of library of functions that works with numerical data. It's called numerical Python, or NumPy for short. Okay? So it's so-called extension or module. The way Python works, everything is modular. And you can import any module that exists out there. But it's not imported or taken into account until you do so. So basically, good news is that Anaconda already comes with it, which is the reason for us to use Anaconda distribution. Okay? And if it didn't, there is an installation command. This is just for your information. You're not going to need it right now at all. There's an installation command that says pip install NumPy. And it works in a similar way for any other package. You need to know its name. In this case, it's NumPy. So it works that way for pretty much any other package. You could create a package on your own and share the file with somebody, and you would install that package in pretty much the same way. Okay? So we're going to tell NumPy or our programming environment that we're going to use NumPy. And since a lot of commands that we're going to use are NumPy commands, we're going to shorten our writing by referring to it as NP. So import NumPy as NP will be one of the first things you will ever sort of type in. So let's do that. And with any more information, there's numpy.org that has more information. So let's do this first thing. And I'm actually going to start a new file, and I'm actually, whatever I type in today, I'm going to type into a file so that I immediately have record of what I'm doing. And I suggest that you do so as well. You might need to change that file as you go to kind of just fix your errors, but it's good to have that record. So I'm going to say import NumPy as NP. And I'm going to save this. I'm going to say NumPy. Though I have uploaded a similar lecture as lecture 2.2 on your canvas. So maybe I will do that. Okay. Now, right now, I have just saved it into a file, so nothing has happened. In order for something to take effect, I have to run the file. And I'm using that little button as a shortcut to running. Otherwise, in general, the way I run the file is by saying run file and specifying its name, as well as working directory. So let's now start defining an array. Again, now every function that we are using from NumPy, we're going to proceed with NP dot, and then the name of the function. And the way we define an array is by using np.array. And since I want to define an array, I'm going to say my array C. I'm going to start with a vector or a one-dimensional array. Array is a function that is going to take in what I type in. The moment I have a function, I have to give stuff to that function
by using brackets. Okay? And what am I going to give it? Does somebody give me an array of 3 numbers? 1, 2, 3. Yes, when you don't know what to do, just do 1, 2, 3. Sure, why not? So I gave it those 3 numbers in angular brackets. That's reserved for defining that this is a sequence, okay? And I am going to copy it into that file. And now I can see, there is a new variable called C. Type of numbers in there are integer 64. And the size is 3, empty. This is a one-dimensional array. And its size is 3. Now if I change it slightly, and remember that upper arrow will call the previously executed command. Say I add the 4th one. Okay. This will change. And you will see that the size has changed to 4, empty. This is again indication of a one-dimensional array. Yes?
What's 32 and 32?
That's fine. That's a choice that your computer makes based on the available memory. And mine apparently is greedy. So 64 is 64 bits. Each word on a computer is 1 byte or 8 bits. We're going to get to that. And your computer is choosing to save these numbers as 32-bit numbers. So 32 bits. I have 32 bits. And mine is choosing 64 bits, probably based on some settings. This is actually kind of important. Now, numbers 1, 2, 3, 4 fit into either description. But 32 bits or 64 bits defines how large is the largest number I can store. There are limits on it. Okay. We cannot store infinitely large numbers. For all intensive applications here, both int32 and int64 work just fine. Okay? So again, just to make this point once again, as I change the number of these input numbers that I'm defining this array with, so does my dimension change, and dimensions are important. Now if I wanted to just, I can observe this here, but I can of course use my friend function print, which we introduced last time. This is a general Python function, and it's going to print this array. Yes?
I don't know if I'm missing something, but mine said it was like error and NP is not.
Did you do import NumPy as NP? Did you type it in?
Console, not in the...
And you have to execute it. You have to execute this file.
Yeah, I copied all of it.
So then you will. So I'm just gonna take the last and copy into the file as well. Okay. And I can always re-execute. Okay. Everything. Excellent. Now we can work with this. What's nice is then I can say print 5 times C plus 1. If I go 5 times vector, or let's just do first 5 times vector. Is that what you would expect for a scalar times a vector based on your completed homework? So that's 5 times C, okay? I could now define another one. Whoa. I'm not sure what I did, Rich. So I can also define another array, and I'm going to call it D. I'm just going to change something to 1, 2, and 0, 0, 0. And I could say C plus D. Is my result correct? I can see both C and D up there. And needless to say, I can do any linear combination I please. Now let's define E as another array, also 1D. So when I'm typing things in, I kind of immediately type in brackets, then I go inside, and then angular brackets, and then I type in what I need in terms of numbers, just to kind of make sure that I include all of the brackets. Yes?
It keeps on telling me my NP is not defined.
Important. Okay, can you come? So you try to type in import NumPy as NP again. Okay, and let me just do another one. I'm going to say 3, 2, 1 now. From what you know about vectors, can you do D plus E?
No.
Shouldn't, but let's test. Operands could not be broadcast together with shapes 5, and 3, So it's using a little bit of a cryptic language, but all it's telling us is I can't do this. Okay. There's one interesting thing that it can do. If you just say D plus 1, it's going to do it. Even though 1 is scalar, D is a vector, this is a shortcut. This is not a linear algebra, strictly speaking, correct operation. Okay? So beware, because shortcuts, even this D plus E, though that's a dangerous one, 3 years from now, some programming environment might just decide to fill in one of the shorter vector with zeros and just proceed. Which, if that was a mistake, it's not going to let you know that it's a mistake. It's just going to do it. So that's something to always, whenever you are in a new programming environment, take a couple of tests that you know what it should be doing and test what it is doing so that you get acquainted with what it is actually doing. Okay? Now, these are arrays, and this is all excellent when I'm working on an entire array. Now I'd like to refer to individual elements of this array, especially when I want to program to do something with it. Now, 1 is the first one I have in there, 2, 3, 4, 5. This is now, again, something you have to know about the programming environment you're in. The first element could be regarded as the first element or 0th element. There are essentially 2 camps in terms of programming languages. Python is in the 0 camp, so everything starts with 0. Okay. So to get actually this 1, I need to print C of 0. And it printed indeed 1. So my initial element is 0th element. So whatever linear algebra has taught you to start with 1 starts with 0. And that's a little, it takes getting used to. Yes?
What's the shortcut for someone wants to getting both? Like brackets?
Getting there.
Oh.
Okay. So you mean first two elements, or?
Oh no, I was just gonna say like, is it like shift one bracket and it makes both of them, or is this not this?
It typically fills it in by itself.
Oh, maybe mine's just stupid.
And maybe yours doesn't, but which is again some sort of setting. Look for autofill setting somewhere. Okay. If it's there, it's called autofill, most likely. So how would I get 5 out of this? C of 4. Cool. So we know how to define array manually so far. And we know how to refer to the elements. There's one shortcut for the last one, just for fun. The last array is -1. So sometimes in your programming, you don't even know how big is your array, or you need to inspect. Okay? Or if you don't want to know how big is your array, but you just want that last member, you're going to get it with -1. And -2 works as well. So what would C of -2 give you? 4. So it just kind of goes backwards. Okay? Let's try to abuse this. Whoa! Well, you can't ask for what doesn't exist. And when you're testing something, obviously I went into this knowing that -20 is garbage in this for this array. Okay, do it, try it, just to see what kind of error it gives you. Okay? Because that will get you more accustomed to the errors that you will sometimes. Maybe you will type in 20 by mistake. Okay? And when you see this index error, you will know, oh, I mixed up some indexing, right? So don't be afraid to make a mistake. Make them often so you get used to them, and then you'll get better at catching them. Okay? Okay. Let's now move on to matrices. So this is arrays, and I'm just going to record some of this in my, if you were typing into command line, please do so. The file that I have uploaded for you, the Python file for Lecture2, it does actually have comments, what all of these mean. So you can use it for studying. I'm not as good as talking and typing at the same time, so I don't type comments as I go here. Any questions before we move on? Yes?
What does it mean when you did print C and then type the number in the bracket?
I'm taking an element, an element from this array. Okay, just one. I could take. Well, thank you. Now I'm gonna take that as an introduction. We could take multiple. In which case I'm gonna put something like this. Let's do 0 through 4. This is the part where I really, really don't agree with Python on how they did this. So this is actually a range of elements or a subset of elements, 0 through 4. What it did is when I told it start with 0, end with 4, it did not take that 4 into account. So 0 through 4 really means 0, first, second, and third, which is 4 of them, not 5. Normally for 0, 1, 2, 3, 4, I would expect 5, right? Except that it drops that last one. I think it's really annoying, but I can't change it. Because I have to constantly do this -1 operation in my brain, which when I code at 2 a.m. can be a little taxing. I would really like it to put the endpoint in there, but it doesn't. Okay. So does everybody see what it's doing? 0th element is 1. First element is 2. third is 3, fourth is 0, 1, 2, 3, and then fourth would be CO4 is 5, but it doesn't include it, this last one. So this is a way to get a range of elements. And then in this case, all of them would be included by 0 through 5, with the understanding that CO5 actually doesn't exist. That's out of bounds because there are 0, 1, 2, 3, 4. Questions? Can I move on? Everything clear so far?
So when you're calling a range, you have to go to 5. 5 doesn't actually exist.
So you have to kind of minus 1 in your... Okay. Excellent. Now let's move on to multiple dimensions. Here's how we're going to let it know to get... Yes?
Does it distinguish whether these are row or column vectors, or they're the same?
If it's 1D, it's always going to use it as a row vector,
Okay.
but it doesn't really distinguish. That means this 0, this dimension here, doesn't exist.
Okay.
If I wanted to distinguish row from column, I have to specifically specify a 2D array that has only one row, or a 2D array that has only one column, and force the dimension to be 5, 1. And this is important because some environments actually kind of take 1D as a subset of 2D and immediately just work with that. This one does not really. But when we will be multiplying arrays, so 2D and 1D arrays, multiplication of matrix and a vector is taken into account, so you can actually give it this, which always appears to be a row vector, which is 1D, and it's going to work with it. It's going to do that multiplication. Let's test that. Okay? So first I'm going to define myself a matrix. I'm still going to use NP array. And now I'm going to go give it row by row. So can somebody give me a simple 2D matrix? 1, 2, 3, 4. Shall we go with that? All right. 1, 2 is my first row, and then comma, 3, 4. So this is why it's useful to type in those. So there's curly brackets, which belong to np.array function. Okay? Inside of that, I'm giving it an array, but it's really an array of 1D vectors, this 2D matrix. And if I was giving it a 3D array, I would kind of, this is a 2D, so 3D array is a multiple 2D arrays. So I would add one more set of outside brackets and follow the same logic. But for now, let's stick with 2D first. So if I do this, let me check out how is my variable explorer doing. Kind of having hard times showing all of my A. And I apparently can't change that, but you can see it's 1, 2, 3, 4. I can always print A. And I see now it's a matrix. What does it say about the size? How would I add one more row using this logic? Comma 5, 6. Yes. So this entire row is like a vector, so you just give it one more vector there. And then when I print A, I have 3 of them. So row by row, you can just keep going. Now, is this legal? Why not? What's wrong with the third row? Should have 2. I'm going to be strict about that. Okay? Oh, it actually did something? But it created a strange 3D object. It says object, so it took it. Technically shouldn't have. But it now created this array with multiple defined dimensions within. And it just says, well, this is an object with 3 things in there. Which is kind of a bad way to go. So I'm going to go back with my classical so 3 by 2 matrix. I can inspect shape. By using function np.shape. So it's going to give me 3, 2. Now here's something kind of possibly weird. The same thing I will get by saying a shape. This is a feature of so-called object-oriented programming. This object, A, comes with actually a set of functions that are kind of traveling with it, or their definitions are traveling with it. So either way, there's an outside function that takes this A and inspects its shape. Or I can say A.shape, which means that like whatever shape function that travels with this in the array, give me a result of it. In which case, this function takes A as its input. And that's a little confusing, but both ways work. Or if you have a variable explorer in the size column, you will see what is the shape of this matrix. Now I can do with this just like I could do. I can say, hey, give me 5 times A. Whoop. If I correctly type it in. And I get 5 times A. Similarly as before, if I add just 1 to this entire object, it's going to actually add 1 to every element of A, which in linear algebra, you would get a negative point for doing that. But this is just a nicety, so we don't, it's just going to add 1 to every element of the array, no matter what the array is. So rows and columns, again, start with 0. So how am I going to, for A, let me print A again. How am I going to grab 1 out of here and work with it? What am I? It is in which row? Which is the 0th. And also 0th column. So this is row 0 and column 0. So the way I grab that is a 0, 0. And that's 1. You don't always have to use print. But frankly, so sometimes just by typing it in, you're going to get what the value is. But that particular behavior can change from one environment to another, so which is why I kind of consistently use print function. So how will I grab element 6? Let's try 3-1. Whoa, no. So my rows again are 0, 1, 2. There's 3 of them, but there's 0, 1, 2. Again, don't be afraid to make a mistake. And you will see me make mistakes in front of you all the time. That way you learn and you kind of catch them as you go. Yes. This one? So it's upper arrow on your computer. So you can go with up, 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 up. This is called the history of commands. And I can now, when I'm here, whatever that line historically was, I can go down. Everybody caught this? I can move up and down in history of my commands. So I go up 1, down 1.
Is there a way to print the
History, yes, there's history log. And you can copy this into here. I didn't want to immediately introduce that last time. Same thing as before. So one couple of more things, just one more thing. So you can give it a range. What would the range be? That's my row 0. Okay? I can also just do this, which means all. This means all. All right. I see you on Wednesday.